Hey, what's up, everyone? Good morning, good afternoon, good evening, whatever time of day you're deciding to watch our next installment for Lecture 2 for Earth 162. So, what you just watched in a previous video is what temperature is. And so we, talked about the difference between heat and temperature and how we measure temperature here at the surface and kind of some variations within that. And now I want to talk about how we measure temperature in the upper atmosphere. So I want you to think about this for a second. How do you think we measure temperature in the upper atmosphere? Just think about it first. And I also want you to consider, maybe you already have a thought and you're like, well, duh, we'll definitely talk about that. But I want you to think on how we could measure the temperature and really any other aspect of the upper atmosphere, but with an instrument that goes all the way up. Not just with something like a satellite that's super far away, but how do you think that we could measure temperature as something goes up into the atmosphere? Did you think about something called a weather balloon? If you thought that initially, then you would certainly be correct. So what we do, or what is done professionally, is launch weather balloons. So these weather balloons are called radiosondes. Maybe you heard about the Chinese weather balloon, which they said was a weather balloon, but some folks, conspiracies like it was a spy balloon or whatever. Basically, this big old helium balloon that gets launched. These get launched all over the world at different locations twice a day. Twice a day, every day. Oh my gosh, why did balloons just go up in the thing? That's pretty funny. I don't know why I did that. So we utilize something called universal time. And that's great because if you're launching balloons at the same time every day, you want to be on the same time schedule. So here in the United States, around the world, we launch at 0Z and 12Z. For our purposes, you can just think of that as 5 a.m. and 5 p.m. here in Pacific time. But if we were in, say, Iowa, where I'm from, right? So if you were at the Davenport airport and you needed to launch the weather balloon, you would be doing that at 7 a.m. and 7 p.m., right? Hopefully without any sort of weather impacting you. Like if there's thunderstorms going on, like really, really close nearby, they'll tend to not launch balloons. It's dangerous for people to be outside. But they'll still do it in the bitter cold. I had a friend who used to work at the Bismarck, North Dakota National Weather Service, and he would have to go out in the bitter cold, like -20, -30 degrees Fahrenheit, and launch these weather balloons. I will say, from my understanding, they have started to kind of automate this a little bit, where you're not having to be the person that goes outside and allows the balloon to go up for kind of said reason. So it's not as dangerous for humans to go out there. Also extraordinarily uncomfortable if it's really, really hot or really, really cold, things like that. But basically, yeah, so these are launched all over the world. And what's really cool about these, notice that there's this kind of big old balloon here, and there's kind of a little marker flag on it. This is for the FAA regulations. So planes are very, very well aware of these launches every day. And there's a little instrument box here at the very bottom. So these instruments take measurements of temperature, dew point, wind speed, and direction as a function of height, right? So as this balloon goes up, 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 it's continuously taking these measurements, right? And an enormous amount of information can be determined from just one sounding. So you're like, sounding? What is that? Oh, and by the way, this was me and a friend of mine, or a colleague of mine, Emily, who went out to the Oakland airport and watched a launch from there and helped out actually for the launch from there, which was really cool back in, oh gosh, too long ago, 2013. I don't want to talk about how that was over 10 years ago. So how we can produce this information onto a graphical sort of thing so that we can easily interpret this information is something called a sounding. So that's what we're looking at here on the left-hand side. So the red line in this case is indicating temperature, and the green line is indicating dew point temperature. We'll talk about what dew point temperature is in depth later on, but how you can imagine it is basically the amount of moisture in the air at one given time. So in this case, when these two values are really, really far apart, the atmosphere is drier. When they're really close together, the atmosphere is more moist. So and I very much apologize if you are colorblind. I understand that some of us with color blindness, the red and green look the same. I don't have power to change that here in this case, so I very much apologize. Just know that the one on the right-hand side is temperature and the one on the left-hand side is dew point temperature. And usually, these values here in the dotted lines, these are altitude indicated by pressure. And then altitude on the left-hand side is indicated by kilometer, and that's a general average. This does vary. And then on our x-axis here is temperature. So as you can see, temperature generally decreases with height, and we will come back to this idea later on in this semester. But in general, temperature tends to get cooler the further up we go. And if you've ever been to the mountains before, you know that it is cooler generally. The higher up you are in the mountaintop, the cooler it is. So this is an image from your book that's used, but this is how it's used kind of in the real world, if you will. So this is a sounding generated from the Oakland airport, and this was in February of 2024. Once again, the red line here is temperature, and the green line, like neon green, is dew point temperature. And so what we do with this information is we computers take this information and from all of these locations and then basically overlay it or superimpose it onto a map. And we'll often look at different pressure levels to get an idea of, say, where the jet stream is, which is what we are looking at here on the right-hand side. So the 300 millibar level, which is basically about 36,000 feet, roughly. That information from the Oakland airport is taken here. And I know it might be a little bit small on your screen, so I apologize. Hopefully you're able to have a look at these slides a little bit larger. But you can see this little wind barb here, this little thing that has a triangle on it. And you can match it quite nicely to the one that's over here on the map, indicating where Oakland is, right? So it takes the information given from this sounding, from all the soundings that are launched, and then we are able, or a computer is able to nicely paint us a picture of what the atmosphere is looking like at that given time. And what the atmosphere looks like tells us a lot about whether that's happening right now in a certain area or whether that could be happening in the future for another area as these patterns progress into the future. It's a pretty cool thing, I think. We'll talk more about soundings later on in a way, and kind of try to bring back these ideas of these twice daily measurements that are being taken. I will also mention that sometimes when there's a severe weather outbreak, like say in the Midwest, if they're expecting a lot of tornado activity, they will launch more than 2 a day. They'll try to launch several ahead of a severe weather event so they can get an idea of what the atmosphere is looking like at that particular time. And it's super, super important to be able to forecast that, to be able to warn people of something that might be happening down the line. So I know we're not going into tornado season necessarily, I should say, in the fall semester, which is what this video is for. But if we were to be taking this class in the spring semester, then we would kind of see this a little bit more often. And so here is just an indication of where balloons are launched from. I have a link here that can help kind of guide you and maybe see not only just where they're located around the United States, but they are launched up in other places too, like some spots in South America or the South Pacific. There's some in Australia and New Zealand, or even over in Europe, right? But notice there are some holes in data. This could be for political reasons. This could be for lack of instrumentation. Maybe some folks don't want to share this information with us, that kind of thing. So the reasoning behind that is beyond the scope of my knowledge, but you can kind of maybe fill in the blanks with those ideas. So basically that's temperature, right? So how we measured at the surface in our previous video and the units of temperature and all that kind of stuff. And now we know how temperature is directly measured through the atmosphere, again, twice a day, every day, at least here in the United States. You could also certainly argue that we use satellites to measure temperature. Satellites are fantastic, but they are not right here taking those measurements, right? They're not directly indicating what's happening. They are using, equations and math and other things to help them determine what's going on. And in the moment measurements are always better than satellite measurements. And that is also super important for tropical cyclone work. So we'll talk way more about all that kind of stuff as we progress through the semester, but I just think it's kind of fun to think about these things as we start to mention them. So that's all I have for us for this particular lecture. Thank you so much for your time and attention. I appreciate it. Be sure to complete the homework for this lecture, and I will see you all again when we meet coming back up. Thank you so much.